We are now looking at test 1, part 2, the solutions. And so the first problem, number 1, f of x is equal to the quantity 2x minus 1 quantity squared. And we are, part A, saying calculate the derivative of this by expanding the function first. And so first we want to look at f of x is equal to 2x minus 1 quantity squared, so this is the same thing as 2x minus 1, all times 2x minus 1. And when we distribute, we get back 4x squared. We have a negative 2x and a negative 2x, which is a minus 4x. And a negative 1 times a negative 1 gives us plus 1. So now we want to go ahead and take the derivative of this using the power rule. So the derivative, we're going to bring down the power, multiply by the coefficient in front, we get 8x. Subtract our exponent by 1, and so that's just 1. Minus the derivative of 4x is 4, and the derivative of a constant 1 is 0. So the derivative of f of x here is 8x minus 4. So now we want to calculate the derivative by using the product rule. And so we want to go ahead and rewrite f of x. f of x is the same. 2x minus 1 quantity squared is 2x minus 1 times 2x minus 1. The derivative, using the product rule, we're going to look at the derivative of the first function. Derivative of our first function, 2x minus 1, and that is just derivative of 2x is 2. Derivative of our constant negative 1 is 0. All times the second function, which is 2x minus 1, plus the first function, which is 2x minus 1, times the derivative of our second function. And our derivative of our second function, which is 2x minus 1, the derivative of 2x is 2, derivative of our constant is 0. So let's distribute and combine like terms. So we have our derivative of f of x is equal to 4x minus 2 plus, distribute our 2 here, we get 4x minus 2. Combine like terms, we get our derivative is equal to 8x minus 4. So for part C, it's asking us to take the derivative using the chain rule. So we have f of x is equal to 2x minus 1 quantity squared. Using the chain rule, we're going to take the derivative of our outer function, bring our power down front, we get 2 of our inner function, which is 2x minus 1. Subtract our outer function, the exponent by 1, we get 1, times the derivative of the inner function. And the derivative of the inner function, 2x minus 1, is 2. Well, 2 times 2 is 4. Take that 4 and distribute it inside our parentheses. 4 times 2x, that is 8x. And 4 times this negative 1 is minus 4. Again, the same thing that we got for the other two. So last part, we're going to take the derivative using the formal definition of the derivative. So we're looking at the limit as h is approaching 0 of f of x plus h. So f of x plus h, we're going in and we're plugging in x plus h wherever we see an x in this function up here, f of x. And so first doing that, we have 2 parentheses 2. We see an x there, we're going to replace it with x plus h. And our parentheses, And then we have this minus 1, quantity squared, definition, formal definition of derivative, then minus f of x, so minus this quantity of f of x, which is 2x minus 1, quantity squared, all over h. So let's distribute that 2 inside the parentheses here of x plus h. So we have 2x plus 2h minus 1. This quantity squared is saying that we're going to multiply it by itself twice. So times 2x plus 2h minus 1 minus, and now we're going to take 2x minus 1 and multiply it by itself twice. So 2x minus 1 times 2x minus 1 all over h. So if we distribute, we get 2x times 2x is 4x squared. 2x times this 2h is 4xh. 2x times this negative 1 is minus 2x. So now let's distribute the 2h. 2h times 2x is plus 4xh. 2h times 2h is plus 4h squared. 2h times negative 1 is minus 2h. Now let's distribute the negative 1 to each term in the second parentheses. So negative 1 times 2x is minus 2x. Negative 1 times 2h is minus 2h. Negative 1 times negative 1 is plus 1, minus this whole quantity. So distributing 2x minus 1 times 2x minus 1. If we distribute and combine like terms, we get 4x squared minus 4x plus 1. All over h. So we're going to want to go in and distribute that negative inside the bracket and combine like terms. And so when we do that, we get the limit as h is approaching 0. So we have a 4x squared. When we distribute this negative, we have a minus 4x squared. Those cancel. We have a 4xh plus a 4xh. That's an 8xh. Let's see, what else do we have? We have a minus 2x, a minus 2x. That's a negative 4x. But then this negative is going to make this a positive 4x. And so those all cancel. We have a 4h squared, no other h squared terms. Let's put 4h squared here. A negative 2h minus a 2h is minus 4h. And then we have this positive 1 minus 1 cancels all over h. So notice we have a factor of h in the numerator that we can factor out and cancel with the h in the denominator. And so once we've done that, we get the limit as h is going to 0 of 8x plus 4h minus 4. And so now as h is approaching 0, plug that in wherever you see an h, and we get back 8x minus 4. And that is the derivative of f of x using the formal definition. So all 4 of those ways, we did different methods but got the same result. And so each one of those, while you're grading, each one of those is worth 4 points. Part A is worth 4 points. Part B is worth 4 points. Part C is worth 4 points. Part D is actually worth 5 points. And then it says up here, circle the letter. And if you circle the letter, the method that you found was the easiest to give yourself an extra point. And so for me, I thought part C was the easiest. But that could vary depending on the person. So for question 2, we're looking at finding the derivative of the following. The first one, part A, we're looking at the derivative of g of x, which is equal to e raised to the x plus 1 power plus e to the x, all over the quantity 1 plus e. And so I noticed that we need to take the quotient, use the quotient rule. And when we use the quotient rule, when we take the derivative of e, we're going to need to use the chain rule. And so when we take the derivative, using the quotient rule, we take the derivative of our numerator first, and our numerator, e to the x plus 1. So the derivative of e, recall, is just itself, e to the x plus 1. Come on. Times the derivative of itself, the exponent, the inner function, x plus 1 is just 1, plus the derivative of e to the x, which is just e to the x, all times the denominator. The denominator in our case is 1 plus e, minus the numerator, e to the x plus 1, plus e to the x, all times the derivative of the denominator. Well, when we take the derivative of the denominator, the derivative of 1 is 0, and the derivative of e is 0. And so 0 plus 0 is 0, all over this denominator, which is 1 plus e, quantity squared. Well, anything times 0 is 0. And so we have this here, e to the x plus 1 plus e to the x, all times 1 plus e, all over 1 plus e quantity squared. And so we can cancel out. We have one factor of 1 plus e in the numerator and two factors of 1 plus e in the denominator. And so we find that the derivative of g of x is equal to e to the x plus 1 plus e to the x, all over 1 plus e. So looking at part B says we're looking at the derivative of f of x equals sine of x squared times cosine squared of x. And so we need to be careful. And by definition, there's a difference. There's a difference between where that square is and what that means. And so let's just rewrite this a little bit. And so this is the same thing as saying f of x is equal to sine of x squared. But this cosine squared of x, that's the same thing as saying cosine of x quantity squared. So I notice when we take the derivative, we're going to have to use the product rule. And within the product rule, we're going to have to use the quotient rule. And so when we take the derivative of this sine of x squared, the outer function is sine. And so when we take the derivative of sine, we know that that's equal to cosine. Cosine of the inner function, which is x squared, times the derivative of the inner function. And the derivative of our inner function, in this case, x squared, is just 2x. Times the second function. Our second function is cosine squared of x, or cosine x quantity squared. plus the first function, which is sine x squared, times the derivative of the second function. So using the general power rule of the outer function, we're going to get multiplied by 2 cosine of the inner function of x. Subtract 1 from our power, we get 1 times the derivative of the inner function. Derivative of the inner function cosine of x is negative sine of x. So we find that the derivative of f of x is equal to, let's pull the 2x out front, 2x cosine of x squared, all times cosine squared of x, times, well, there's a negative here, so let's pull the negative out front. So minus 2 sine x cosine of x sine x, or sine of x quantity squared. If you wanted to, you could start factoring out common factors, but for there, that's good enough. So looking at the derivative of y equals the natural log of the quantity x plus 1 all over x cubed minus 1. So it would be easier if you first rewrite that using properties of logs. And if we have a log of a quotient, we can rewrite that. Quotient means that we want to rewrite that as a minus in between. And so this is the same thing. We could rewrite this as the natural log of our numerator, which is x plus 1, minus the natural log by rules of logs of x cubed plus 1. So now let's go through and take the derivative. So y prime is equal to, the derivative of a log is 1 over what you were taking the log of, x plus 1, times the derivative of the inside using the chain rule. Derivative of x plus 1 is just 1. Minus 1 over what we were taking the natural log of, which is x cubed plus 1, all times the derivative of the inside, which is 3x squared. So our derivative here is 1 over x plus 1 minus 3x squared all over x cubed plus 1. So you might have taken the derivative of this a little differently, just straight ahead without rewriting this using rules of logs, taking the derivative of the natural log, and then when we took the derivative of the inside, you have to use the quotient rule. So part D, compute the following: dy over dx. Y is equal to x times y squared plus 2x. So we want to go through here and use implicit differentiation. And so wherever we take the derivative and it's with respect to y, we're using the chain rule and we want to tack on that dy dx. And so take the derivative of both sides. Derivative of y is 1. It was with respect to y, which is a function of x. So we're going to rewrite this as dy over dx is equal to, so we're going to need to use the product rule here. And so when we take the derivative of our first function x, that's 1, times the second, which is y squared, plus the first x, times the derivative of the second, y squared. Derivative of y squared is 2y, times, because that was a function, y is a function of x, so times dy dx, plus now the derivative of 2x, derivative of 2x is just 2. So we want to get dy dx by itself. So we want to isolate terms with dy dx. Let's subtract maybe this term. And so we have dy dx minus x times 2y, so minus 2xy dy dx is equal to y squared plus 2. Let's factor dy dx out of both of these terms. And so if we pull out dy dx, we're left with 1 minus 2xy equals y squared plus 2. Let's get dy dx by itself, divide both sides by that parentheses. We have dy dx. Our derivative of y with respect to x is y squared plus 2 all over 1 minus 2xy. So problem 3 says we're looking at use logarithmic differentiation to find the derivative of y equals the quantity of e all raised to the x minus 1 quantity squared times e all raised to the x minus 2 quantity cubed. And so we want to take the derivative of, before we take the derivative of both sides, we want to take the natural log of both sides. And so taking the natural log of both sides, we have the natural log. Blow this up. And the natural log of y is equal to the natural log of e all raised to the x minus 1 quantity squared all times e all raised to the x minus 2 quantity cubed. So let's use properties of logs. When we have multiplication in between of what we're taking the natural log of, we can break that up as the natural log of the first function, e all raised to the x minus 1 quantity squared, plus the natural log of the second function, which is e all raised to the x minus 2 quantity cubed. So we have the natural log of y is equal to, so natural log of e raised to the x minus 1 quantity squared. So natural log, by definition, this is saying e, what is our exponent you're going to raise e to get this back? E raised to the x minus 1 quantity squared. Well, that's just x minus 1 quantity squared, plus, same thing here, natural log of e, that cube is in the wrong spot. Natural log of e all raised to the x minus 2 quantity cubed is just x minus 2 quantity cubed. So now let's take the derivative of both sides. The derivative of natural log of y is 1 over y times y is a function of x, so dy dx. Equals, so take the derivative of the right hand side, we're going to use the chain rule, bring our power down front, we got 2 of the inside, x minus 1, subtract 1 from the exponent outside, that's 1, times the derivative of the inside, which is 1, plus the derivative of x minus 2 quantity cubed, using the chain rule, bring down the 3, we have 3 times x minus 2, subtract 1 from our exponent, it's squared, times the derivative of the inside, which is 1. We want dy dx by itself, so we're going to multiply both sides by y. But recall, y is just this, e raised to the x minus 1 quantity squared times e raised to the x minus 2 quantity cubed. And so we get that dy dx is equal to 2 all times the quantity x minus 1 plus 3 all times the quantity x minus 2 squared all times y, and y was e all raised to the x minus 1 quantity squared, all times e all raised to the x minus 2 quantity cubed. So the last problem on the exam, we have f of g of x is equal to e raised to the x squared. We're given that g of 1 is equal to 2, g prime of 1 is equal to 4, and we need to find f prime of 2. So looking at this, let's look through and take the derivative of both sides. So the derivative of f of g of x, we need to use the chain rule there. And so when we use the chain rule there, the derivative of the outer function which is f of x, that will give us f prime of the inner function, which is g of x, all times the inner function, which is g prime of x, this is equal to the derivative of the other side, e to the x squared. Derivative of e is just itself times the derivative of the exponent. Derivative of the exponent x squared is 2x, all times itself e to the x squared. So let's go in and let's plug in x equals 1. So wherever we see an x, we're going to replace it with 1. So we have f prime of g of 1 times g prime of 1 is equal to 2 times, you see an x there, 1, e raised to the 1 squared. So f prime, well, g of 1, we're given g of 1 is 2. So f prime of 2 times g prime of 1, well, we're given g prime of 1 is 4. This has to equal 2 times e raised to the first squared, which is just 2e. If we divide both sides by 4, we can figure out what f prime of 2 is. So f prime of 2 is equal to 2e divided by 4. Reduce, we get f prime of 2 is equal to e all over 2. Okay, so that is the end of the solutions to the second part of the test. Hopefully that helped. You guys saw where you made mistakes and where you went wrong, and now you understand those problems. Hopefully you did well, and I will see you at our next class period.